Yeah, thank you so much. Yeah. So thank you everyone for joining this session. So I'm Stanley Tam from Hong Kong. So although in Hong Kong it's already midnight, but I'm still really energetic to conduct this session and share that how we help enterprise to adopt SRE and DevSecOps practice. Okay. So I think we already introduced myself. Let me skip this slide. So for today's agenda, so actually I will first introduce what is the SRE and the DevSecOps concept. So I believe the panel already discussed some of them already. And then I will also summarize what is some generic customer pain point that we so far experienced in the project. And then I will see how we can adopt it with the SRE and DevSecOps in a real example and use some real cases. And finally, we will have some SRE organization chart that we deployed in the projects. So to begin with, let me talk about what is the SRE and DevSecOps. So you can see that traditionally, the developer team and the operation team is really having some conflict because their KPI or the interest is quite conflict. So for the development team, their KPI is really talking about the time to market. They talk about the velocity. They talk about the productivity of some new features. While operation team, they really focus on the stability, the performance, and the reliability. So they somehow resist changes. So that's because every changes, like the configuration change or the application deployment, you will really introduce changes to the environment and also increase the risk of stability issues. So we can see that there's some conflicts, but also there are also some wars between them that may lead to some lengthy or review process or some communication gap between the team. So that is something that we have introduced the DevSecOps and the SRE to somehow resolve these issues. So DevSecOps is really help to aim to speed the delivery of some software SDLC cycle by combining and automating the work of the software development, so that we combine both development team, also the operation team, as well as the security team, so that we work together, form a cross-functional DevOps team, so that we work on the project from start to finish, so that same group of people, we build it, we run it, so that the communication gap between the team is minimized. Yeah, so that we do the culture change. We also automate some manual process, and also we use some tools to automate this. Yeah, so we can see that the developer is shifting left to the operation team, so that we're also doing some operations of the applications. So for the SRE, you can see that it's quite different. You can see that they're actually shifting right. From operation team, they are also using some software engineer tools or some methodology, so that they based on some historical data, operation data, and some software engineering kind of thinking to automate some IT operation tasks, and also to accelerate the software delivery, and also some minimize the IT risk. So the principle behind SRE is really using some software code to automate the large software system. So that this way is more scalable than some manual intervention, so that when issue happen, then we manually fix. So this is something that is really not sustainable. So that the rise of SRE is really helping that to detect it as soon as possible and do some preventive failure, to do some preventive action on that. So you can see that the SRE and the DevSecOps, they are not really conflicting to each other. Actually, you can see that one of them is shifting left, one of them is shifting right. They are really coming into the same goal, so that they want to minimize the conflicts between the development team and also the operation team, so that the SRE is really closely aligned with the DevOps principle. So that for the standard software development lifecycle, we can see that DevSecOps and SRE, they are really working together, playing different roles, so that they keep minimizing the conflict between the teams and also increase the time to market, or as well as increase the reliability and stability of the environment. So here comes some briefly advantage or business value that the DevSecOps and SRE bring up. The first one is the higher velocity. So that is we measure about the time to market and also the release frequency. You can see that we can do some by empowering the product owner so that we create a cross-function team that work together, build it and run it, so that we empower the power owner to do the decision, to make faster actions to increase time to market. And also we have the CI/CD, so that with the test automation and also build to manage approach, so that we include those management aspect when we're building the applications to increase the operation efficiency. And then we have the quality assurance, so that we can measure by the availability, the change failure rate, and the mean time recovery time, so that when we are doing some introducing some observability of the application and the platform, and also some operation readiness, as well as some chaos engineering, so that when we are doing some chaos or disaster, how we can react much faster than the previous manual intervention is something that we can do it much better when we're using the SRE and the DevOps. And also not to mention is that the high efficiency, because most of the work is being automated by the DevOps or the SRE, and also the scalability, because when we are meeting the user demand, if we have really good foundation of the platform as well as the SRE team, we can minimize the resource usage and also meeting the same quality, the performance. Yeah, we can do some automation, self-service, and also reduce the technical debt. Okay, so here comes is the what's the common enterprise pain point that we have experienced in the projects. So the first one is that we can see that because some of the application in some enterprises really built up a long time ago. So that some of the application is quite legacy, so that they really require much effort to being supported. And this increased the operation expense. More operation team is required to support that. And also the current time to value is very slow. And so that you really slow down the business roadmap as well as the competency. And the third one is the performance is slow, as well as the elasticity for the user demand is really not having a good ratio. So that you can see that the performance is keeping slow, and some application is really not functioning when there's some promotion campaign where the user demand is increasing sharply. And also because more and more enterprises adopting or already finished the cloud modernization or cloud migration, so that the current support team is really not having a full capacity or full technology depth to support those new technology. This also make the team is not really having a full support capability to the whole overall IT landscape. And the final one is that because they lack of some tools, methodology, or the process, they are really hard to isolate the problematic area and also do a fast response for that. So we really based on this pain point, and then we have some addressing them by 3 different areas. The first one is talk about is the capacity planning. So most of the actual problem may be due to the high resource saturations, so that using some capacity planning is really good for customers, so that you can see that we can conduct some capacity planning to ensure that the enough resources is enough for the current application as well as the future budgeting and also future planning. And then we also conduct some trend report to really have some continuous assessment to ensure that enough resources is being allocated for the new applications that will be onboarded. And then we also implement the monitoring mechanism to detect some resource issues in case of any issues. Yeah. And then we have some site reliability and also some platform designing that really help to set up a good foundation whenever there's some new project for that. For example, in one of the projects, we designed a hybrid cloud container platform that increase the availability between the cloud, between the sites. And also we containerize some applications from legacy applications to fully utilize the container benefits to allow them to do some auto-healing, auto-scaling to increase the availability and reliability. And then we also have implement some monitoring model to actively detect any potential issues and also do some remediations automatically. And finally, we utilize some cloud service for those customers that may have some limitation on their on-premise data center, so that we can make use of some cloud service to resolve those issues. Let's say if you are using the Kubernetes, because they may require a crawl mechanism, so that if the customer do not have a third data center, we can make use of a cloud service to act as a third data center. And the third area is talking about is the DevSecOps. We do some automation, also some process redefinitions to help them to automate the standard development lifecycle, so that we standardize the build and the deployment process across the applications. We also enable some automated testing to eliminate some manual testing efforts and also the testing efficiency. And we also establish some deployment strategy, let's say the blue-green deployment, so that we can really testing the application before releasing to the production where the real user is using. And also some change management to do the keep tracking and also to do some quality assurance. So here's the platform designs that we have doing, so that we can form really a solid foundation for the cybersecurity engineering, so that because if you are not having a good platform designs, you can still do the SRE, but it will be much more painful, so that you need to keep catching up or keep helping to improve it. But if you already have some good design, definitely it really help make the life easier. So that here is some 6 examples that we are doing when we are doing a project. So definitely when we deploy, if you are on premise, we deploy our EXSI server, we need to consider the high availability across the multiple sites, or if you are on cloud across multiple regions to ensure the high availability. And then we are also doing some continuous service by running across the multiple workload in a single site to ensure that even if there's a node failure, you can also sustainable in your single site. And also we also need to cater is that we need to reserve some extra VM capacity to do some failover capacity. Otherwise, it may be really hard if you do not reserve some capacity for doing the scale out, scale up, or doing some failover. And also we can use some multi-tenancy features, let's say in Kubernetes OpenShift, so that you can having different type of application workload, different owner, but we can also grouping them, but also with some discipline or restriction, so that we can have a good resource utilization. And also we have some centralized user management by integrating with their LDAP to have a single authentication directory, and also some traffic management for security measures. And then we will talk about is the monitoring model that we are being in place with different projects. Is that there are 4 key areas that we should take care of. The first one is about the dashboard. Definitely for the traditional or operation center, we can see that there are many dashboard being show up. So this is still something that we should make use of, so that when there's any issues, then we can monitor the 4 golden signal: the latency, the traffic, the area, the error, and the saturations. And also we can monitor the self-heaviness, so that we can avoid the issue, detect the issue, as soon as possible and do some remediations. And then the second area is that we do the trend analysis. We forecast any future trend based on some historical data and operation data. And then we can also detect some potential risks and low efficient area that we keep improving on. And the third area is the alerting, so that we can really base on the risk and severity, so that we can prioritize what kind of issue we should take care of, so that we can react it as soon as possible, and some things that we can do it in much more long-term way. And then for the inspection is that after all the free process, if we got some issue that we really need to take a look of or troubleshooting, then we can do some retrospective analysis on those monitoring metrics, and then we can investigate through some different kind of technology, let's say the distributed tracing or the centralized logging, so that we can easily identify the impact area and also the root cause, and we can react it as soon as possible. Okay, then I will come to it one by one. So for the dashboard, definitely this is the area that you really proactively detect any problematic area by using different visualizing dashboard. Let's say the Grafana. Yeah. So it is really correlate some metrics to also connect the symptoms and also the causes, like the surface traffic or the high resource usage or DB usage, DB sessions. Yeah. And then we will focus on those monitoring surface healthless and the 4 golden signal. The 4 golden signal is the latency. So when we seeing that there is a high latency or the slow response, they may one of the root cause that causing the bad user experience. That is something that is really impacting the users. And also the traffic. When there's a high traffic volume that may exceed the server capacity, then we may result in a slow response or even application error. So this also leads to the third golden signal is the error. So in case we receive some abnormal HTTP response, let's say the internal server error, this also may indicate that there is some potential application issue that's really happening or may getting even worse. And the situations is that we need to also take a good care of the resources to ensure that they are not fully saturated. Otherwise, it may become a total loss or total failure of not an individual system, but is the whole IT landscape. So with this dashboard is really helpful for the support engineer to easily detect any abnormal situations, so that they can instead investigate and solve those issues in early stage. So the tools we are using is the Grafana. And then second area we are doing is the trend analysis. So that's our approach is that we based on those historical data, such as the traffic latency, the application log, or the number of incidents, so that we base on those metrics, so that we can do some analysis. Based on this analysis result, we can forecast the trend, and then we can detect some potential issue or some area that we should focus on. We can do it in a long way planning, so that is really useful for us to optimize those costs and also increase the operation efficiency. So there is something, some tools that we can using, of course, the dashboard or some machine learning tools, let's say the ELK stack modules. And the third one is the alerting. So we base on the priority, we prioritize those issues by using different alert mechanism. For example, we're using the SLO, the surface level objective, or the business criticality, so that we prioritize each issue. Let's say for those critical issue, we may issue a critical alert, let's say for those service time, because they will impact all those users using that. Then we will issue a critical severity. Then the software engineer or the support engineer is able to react it based on the criticality of the alert. And then for those minor things, let's say let's say if the application have some dead letter queue, that's something that need to work on, then you may only have some limited impacted area, so that these things can be catered later, so that we can focus on the area that we need to be resolved in limited resource. Yeah, there is some kind of tools that we can make use of, including the Prometheus, Alert Manager, also some APM, ARM solutions, and also some notification, say Slack or email. Okay, then I will have a quick trend analysis using as a case study. So here is one of the real use case that we are being observed in one of the customer. We can see that in the April, we can see that the traffic response time is increasing sharply, and also existed across those months after that. But you can see that in the blue line is actually quite steady about the traffic volume. So the traffic volume is not the factor that contribute the slow response. Then there should be something that should contribute that. Then it's something we should take a look at. Then the second area we were doing, or action we are doing, is the problem isolation. The first things we will check is that how about the resources? Is this resources being highly utilized? We're seeing that, okay, for the CPU and memory, they are only take up about 30 or 40%. So we can conclude that actually it may not be related to infrastructure. So it's something that we make you look at about the application level. And then we could using some technology, let's say the distributed tracing or the dependency map. Then we can see that, okay, we find that in the whole traffic, we can see that the microservice calling database take the most of the time. Then it's really easy for us to identify the problematic area. After that, the support engineer actually found out that it may be due to the recent release change, so that there is some schema changes, but the index is not being created. We observed that during the selecting query, we found that it's a full table scan instead of using an index scan. So after that, the developer applied that indexing. We can see that there is some optimization can be done. And the outcome is that after we apply the changes, we can see that the response time is dropped sharply, so that it resumed to the normal. So you can see that for the trend analysis, it's really useful for us to detect some really not obvious error that the user will immediately experience, but we will find out those potential errors that we should focus on. So here's the final section, is about the organization chart. So here's a quick summary. You can see that in the normal operation experience, we know that there are many channels being received the alerts or complaint. So there is someone that may need to quickly identify what is the impacted area, and also what is the root cause of that. So SRE is really playing a key role here. Of course, it's not only a human doing that, but it's really many tools, like the one we're saying, the dashboard, the trend analysis, also some other tools, let's say the APM, ARM solutions that let the SRE have some metrics or evidence to prove that, okay, it should be something around the application or something around the platform or the infrastructure. Then it's easy for the team to identify which other teams should be focusing on, so that it's easier for the whole operation team to find out what is the root cause and react as soon as possible. So SRE is really playing a key role for helping on this. So here's some key takeaways, so that you talk about the platform building, the DevOps enablement, and also the monitoring model that we have discussed here. Yep, so here's my sharing sessions. So just let me know if you got any comment or questions. Thank you.